is the main string that the robot's going to be ascending going to be the main tether, or is there going to be other tethers to be able to anchor it?
It's a single thread. We have done a tripod a couple times where you had a primary and then one or two safeties. This was a mess. It was really difficult to manage. If the winds happened, you'd have situations where the wind would come in like this or like this, and it didn't help, and it actually made for a much more complicated system. When we went to MIT, we had a cantilevered arm off the side of the building with tethers down to the ground and the robot climbing up and forth. So this was about 17 stories high, so it was pretty high. It was the beginning of a snowstorm, and the winds were whipping around. It's MIT, right off the water. And at the last minute, the security guard required us to put a safety line on the system. So you have your primary ribbon that the robot's climbing up and down, and a safety line. Well, if you put wind and two lines together, they're going to naturally whip around, and they tangled. And the robot was climbing up, got about 50 feet up, and it just stuck. It just stayed there for about like a minute or two. And I was about to call off the experiment, and it was really embarrassing because there's about 100 kids down, students down on the ground, and who knows how many were actually watching from the windows. I'm on the ground in the snow, in the rain. It was terrible. It was freezing cold. And I'm just looking at this thing getting stuck. And then all of a sudden, the robot snaps the safety line and keeps climbing up. Now, it climbed a lot slower because now it's got this extra line in the treads and everything. But that was a pretty good day, actually. It started looking terrible, but it ended really well. So we don't add any more extra strings. We do enough testing. We have confidence in the string that, you know, if it breaks below the certain threshold, well, then we have other problems. But we have done plenty of testing with this stuff, so we're pretty confident we don't need other strings.
Do you think that the single string, once it has the full pressure and tensile strength with it, will be able to keep the balloon from drifting due to wind?
Weather dynamics in the United States, basically the wind comes off of the Pacific and aims for the Atlantic. And so every experiment we've ever done, the ribbon has been at an angle. Sometimes here, that's not very often. Usually it's around here. It's a combination of how much wind drag is there on the line itself, how much of a sail area of the balloon itself versus how much lift you've got. And what always happens is the robot's climbing up, it changes the angle. It almost, even though obviously it's not two strings, it actually acts as two separate strings. If the robot is here, it changes the center of mass of the whole system. So this acts like a separate string, and this acts like a separate string. And then as you get higher, so it starts out kind of wonky like this and eventually becomes a little bit more straight. This will be our 19th or 20th robot, 19th robot, and our 15th high altitude balloon experiment. So we've kind of done this a little bit, and we kind of know what to expect. The balloon will have, I'm going to make up numbers now, don't quote me on this. So the robot's going to be about 10 kilos all total, 20 pounds-ish. Okay. We'll have about 100 pounds worth of lift in the balloon. The string is, because we're not going all the full distance, the string will be about 15 pounds. So that's almost a 2.5 to 1 ratio or so, and that's kind of what we aim for. We aim for a 3 to 1 ratio normally. So whatever that total mass is, the string plus the bot plus the batteries plus communications, we'll aim for about a 3 to 1 ratio on that. And that gives us plenty of lift. What could happen, though, is there's a lot of wind all of a sudden. That puts a lot of pressure on the system, and that tightens everything very, very quickly. The wind loading can be hundreds and potentially thousands of pounds almost instantly. So that's what our big concern is. That's why we're overpowering the strength of the string to deal with the wind loading. We won't have that problem on the moon. So that's simplified. So the string that we would use for the lunar system actually can be this thin, whereas when we build it on Earth and do our testing on Earth, we have to account for Earth-like conditions. Does that make sense?
Mm-hmm.
Yeah, so that's what we're doing.